All right, so lesson 5 of chapter 4 talks about comparing two functions. Now, you really have two things whenever you're talking about when you compare two functions. One is the rate of change, or the slope, and the other is the y-intercept, or the amount whenever x is 0. So either way you want to look at it. So we're just going to be comparing two things. One they're going to give you usually in the problem, and then the other they are going to give you an equation. You just have to compare it. So example 1, a zebra's main not competitor, how about predator? A zebra's main predator is a lion. Lions can run at a speed of 53 feet per second. That is a rate, or a rate of change. All right? The graph at the right shows the speed of the zebra. So what is the zebra's rate of change? Zebra's rate of change. So you can take any two of these points and do your slope formula. So they chose 118 minus 59, so change in y over the change in x over 2 minus 1. So they got 59 over 1. So this is the zebra. This is the lion. So it says compare their speeds. So if you compare their speed, you're going to see that a lion is 53 and a zebra is 59. So actually, a zebra is faster than a lion. So really, there should never be a zebra being eaten by a lion, but we all know that that doesn't happen. So that's what they're talking about when they say compare. Find the rate of change. Really? Already? Jeez Louise. All right, you try got it. Come back to me and we'll see how you do. All right, a certain car has a gas mileage of 22 miles per gallon. That is a rate right there. That's the car's rate. So the gas mileage of a certain SUV is shown here. So find the rate of the SUV. So a car has a rate of 22. An SUV has a rate of, let's just do these 2 points, 38 minus 19 over 2 minus 1. So that's 19 over 1, 19. So compare their gas mileage. A car has a better gas mileage because it has 22 and the SUV is 19. Give me a sentence, something like that. All right? Now, let's move on, and hopefully we can just move to the next page without going halfway through the book. No, the answer to that would be no. Why, oh why do you hate me? Silly Promethean board, you're making me sing. Yeah, and I really can't sing at all, so sorry about that. It's that or yell. Done. All right, so the function m, example 2. M equals 140h, where m is the miles traveled and h hours represents the speed of the first Japanese high-speed train. So there's a lot of word problems in this. Lots of word problems. So do your best with that, those of you who hate word problems, which are the majority of you. So Japanese train. Japanese train, the rate of change, which even whenever we have our y equals mx plus b, or even our direct variation of y equals mx, the rate is always the one in front of the x, right? So the Japanese train's rate, 140. Let's talk about the Chinese train's rate. It's given to you in the table. So to find the rate of change, just subtract. Use our y2 minus y1 over x2 minus x1. So I've got 434 minus 217 over 2 minus 1. Bottom's an easy one to do in your head. Top one, 434 minus 217. I don't know why I put that number in there. That is, sorry, that line, that is not a divide. So let's try this again. minus 217. Don't want to confuse anybody. So 217. 217 is the rate of the Chinese train. So since that is faster than the Japanese train. So assume the relationship between the two quantities is linear. Okay, got it. So compare their functions and y-intercepts and rate of change. So with that being said, if you ride each train for 5 hours, how far will you travel on each? How far will you travel on each? Okay, so for the first one, m equals 140h. So if you ride it for 5 hours, you're going to substitute in a 5 for the h, 140 times 5, 700 on the Japanese train. Now, looking at the Chinese train. So, Chinese train, you will travel 700 miles. Oh, sorry, that was the other one. Find the distance on the Chinese train by extending the table. So, if the original table, right up here, we're talking about for 1 hour, this, 2 hours, this, 3 hours, this. Well, what would it be for 4 hours? Well, it's going to be another 217. What would it be for 5 hours? Another 217 on top of that. That's what they did. So you can extend the table out to find the distance after 5 hours. So on the Japanese train, 700 miles after 5 hours. Chinese train, 1,085 miles after 5 hours. All right. Makes me a little gun shy when I do this. Okay, try this under got it. Pause it, come back to me, please. Okay, looking at this one. If we talk about compare the functions y-intercepts and rate of change. So the function for the movies has a y-intercept of 2. And I know that because if I put in a 0, right here, that would totally take that one out. So the y-intercept for movies, y-intercept is 2. Okay, this is more of a linear relationship. This is more of a direct variation because it's this, 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 this. So we've got that y-intercept is 0. Y-intercept over here is 0. So after 0 weeks, you're not getting any games. So the y-intercept is 0. The store receives 7 movies per week and 3 games per week. 7 movies per week and 3 games per week. 7 movies and 3 games. Now, how did I figure that out? That would be their rate of change, 7 movies and 3 games. So if I take this off of there, you know that the number in front of the x, or in this case, w. So 7 movies per week, that's their rate. And over here, what is the rate of change here? Well, for every 1, this goes up 3. So the rate of change is 3 for the games, 7 for the movies. So how many new movies and games will the store have in week 6? So in week 6, for movies, you would just substitute in a 6 right there. So movies, 7 times 6 plus 2. So we'll have 42 plus 2, 44 games. Now, for week 6 here, week 4, 12. Week 5, 15. Week 6, 18. Notice I'm just doing what every time? This times 3, this times 3, this times 3, times 3, times 3, times 3. That's why this is more of a direct variation. Direct variation. The rate is 3. So how many will they have? It's 3 times the number of weeks, which is 6. So it's y equals 18. 44 new movies and 18 games. All right. Let's try another one here. Really. Is anyone else quite annoyed with this as I am? Or maybe it's just me. Yeah, not even close to that. Really? Page set up? Mm-hmm. Oh, disappear. All right. All right. Angela and Benjamin each have a monthly cell phone bill. Angela's monthly cell phone bill is represented by the function y equals 0.15x plus 49. What in the world does that mean? Here's what that means. I'm having all kinds of technical issues today. What does that mean? That means that this is how much she is paying per minute. It says x equals the number of minutes. So she's paying 15 cents. This is Angela. Come on. That looks nothing like Angela. Let's call her Ange for short. 15 cents per minute. Now, when we talk about Benjamin, how many cents per minute is he doing? We have to find his rate given by this. What is the rate? 72 minus 60. y2 minus y1 over x2 minus x1, which is 0. So we've got 12 over 120. If we divide that out to find his rate, it's 0.1, right? Or 10 cents. So Ben, 10 cents per minute. Okay. So, and this is also saying that no matter how many minutes she uses, she has to pay 49 minutes just to have the phone service. How about this? For 0 minutes, he's still having to pay $60 for the phone service. So it wants to know, what will the monthly cost for Angela and Benjamin be for 200 minutes? For 200 minutes. So let's do this. What is his, we've got this, Angela's. So for 200 minutes, 0.15 times 200 plus 49. That's Angela. Ben, his rate was 10 cents a minute, and we're talking for 200 minutes. And how much does his phone cost just to have it? 60. So plus 60. So if you work that out, if you multiply and then add 49, Angela will pay, what will Angela pay? Angela will be paying $79. What will Benjamin be paying? Oh, Benny boy, he will be paying $80. So, after all that, he's only paying $1 more, but he is paying $1 more, and that's what they're asking you to do. Okay? So, I want you to try one more. Try got it, and then we'll be done for today. Pause it and try it, please. Sorry, I guess you need the equation put up here before you pause it and try it. Now that it's up here, let's pause it and try this one, please. All right, back with me. Let's do what it says to do. It says to compare the y-intercepts and rate of change. So just looking at this. For Mandy's membership, the rate of change is 3. And her y-intercept is 29. And I get that just from this equation right here. So when we talk about Sarah is the graph. So what is Sarah's? And I guess I should probably put Mandy over here. Sarah over here. Come on. Sarah. There we go. Sarah's membership. So Sarah's rate of change. And you take 75 minus 51, which would be 24, over 12 minus 4, which is 8. So what is her rate of change? It is also 3. But what is her y-intercept? Y-intercept is 40. So what does this mean? Well, what does it mean is that they have the same rate. Their same rate of change is 3, but Mandy has to pay $29 a month and poor Sarah has to pay $40. All right? So that's the reason for looking at for the rates of change. So look over these. If you have any questions, let me know. Good luck.